Contract testing.
Thank you. Yep, my name is Indrek. I come from a company called Concise. Probably not well known yet. We work with high growth companies, mainly currently from Scandinavia. We do our work in a super agile way, meaning that we combine different processes, methods, and technology to achieve or help our customers to stay ahead of others and their competition and achieve minimal time to market. One of the things we practice is continuous delivery and deployment. And I think this is kind of like a good segue into today's topic, which is consumer-driven contract testing and how this kind of method helps you to achieve that. So to explain what this thing actually is, I would first start with some examples. I'm going to set the scene with a fictional e-commerce company who they do a microservice-based architecture, and they have different services in their environment running. So, for example, they have the usual billing service, for example, and the customer service. And these services talk to each other using HTTP. So billing needs to access customer information, for example, to do billing. So after a request to the customer service, customer responds with some customer information. So one day or night, the customer team was working on their code, and they noticed that, or at least they looked at their what they were responding to the billing service. So perhaps it's not quite well seen from the back, but the payload includes a customer ID and a name and other stuff, but they looked at it that this thing is not customer ID, this is customer ID. So technically a typo. So should it be customer ID then? So since the team was perhaps not a native speaker of English, so what they did, turned to Google, googled customer versus customer, and what they found was that, yep, that was a typo. Customer is somebody who makes costumes or supplies costumes. So embarrassing mistake, had to fix that quickly. So they made a new build, new version of customer service. The customer service now actually they fixed the typo. It says customer ID. They pushed to production, went home. Next day, billing guys weren't so happy with that, meaning that the billing service did not expect this kind of payload to be responded from the customer service. So that raises some questions like, didn't they do any testing? So kind of like an obvious situation. So first, before I'm going to talk about testing, let's have a look at this classical testing pyramid. Who has seen this one before? So basically all of it, almost. So this pyramid kind of states that you should, there's like 3 different types of tests. You have unit tests, which test some unit in isolation. You have integration tests, which test how the different units integrate with each other. And on top of the pyramid, you have end-to-end tests, meaning that you set up all of what you have and test them together. And this this diagram also explains that what's in the bottom of the pyramid, these kind of tests are usually fast and they are cheap to maintain. And the higher you move in this pyramid, the slower the tests become, and also they are more costly to maintain. So let's start with unit testing. Did the customer team have any unit tests? Since we're currently talking about microservices, let's define a unit as a single microservice, and that is being tested in isolation, for example. Turns out they did have tests for it. they spun up their customer service. They mocked all of their external dependencies, including the database, and they had some test code which made the request, got the response, everything was fine. Then they made this new build of customer service, which responded slightly with a different payload. They run their test as usual. Now with this fixed, they fixed the typo, but now they saw that the test failed. This should have been a sign already, but what developers do when a test fails, they fix the test. So they rerun the test again, everything was fine. On the billing server side, they also use test this kind of way. They had a mock customer service. Basically, this is a kind of a dummy. They already define some inputs and outputs that the mock customer service, how it behaves. So they kind of poked their billing service in a way that it made the request to the mock customer service. Here, the mock actually responds with this typo, and their test was also fine. So we tested these separate services in isolation, everything was fine, but on the whole, there was still an issue. So tests that mock dependencies, if we look at them all together, they are fast and also cheap to maintain, fast to run. They are targeted, meaning that if a test fails, you will have a very clear understanding of what failed, because this single test focused on a single area. Yep, you have a question?
Yeah, the previous slide that you showed, was that a unit test?
Depends on how you want to look at it, but technically you could test some part of this billing service that actually make. You mean this one?
Yes.
Yep, they kind of mock everything that's on the outside. They have some tests. Basically, they give some input to this specific customer service and look at the response.
Just weird that unit test made a network request, or?
As I said, when I'm talking about unit testing in this microservice context, I'm talking about a unit as a single microservice and testing it in isolation. I mean, yeah, it's debatable. Is a unit test a class or a method or function? But I'm taking a bigger approach here. So yeah. But they are not trustworthy in a sense that, as we saw, that these mocks that they were testing with, these mocks, they made some assumptions like how the other collaborator should behave, but there was no process in place that actually verified these assumptions. So if the one side changes, the other side probably didn't get to know about this until it was too late. So that was testing this one thing in isolation. But since we are dealing with two different microservices, this kind of seems like an integration issue, two things, did they integrate well together? So what about integration tests? And now when I'm talking about integration testing, I'm talking about taking one service, other, and making sure that they play well with each other. And this test kind of assumes that we run them both together and see that if they work. How it could look is we set up a new environment somewhere, start the billing service, also the customer service, and somehow play with the billing service so it actually makes this request that we are interested in. Since now this is the new customer service with the fixed, where they fixed the typo, this test should have failed and they should have seen that, okay, something is wrong. But turns out this team didn't do this kind of tests, and I'm now going to explain why they opted out of doing these kind of integration tests. So if the customer team made a change to their API technically, they would also have to run these tests on all the other services that actually consume this customer API. So let's say they also have some kind of inventory system. So they would have to run this test with this system as well. Also, this team was interested in an independent release cycle, meaning that if they tested the services together, it would they give them confidence that exactly these versions will work well together. But if they wanted to release their service independently from others, this would mean that this kind of approach that I just showed probably would not work, because they would still have to, if they tested these together, they would have to deploy them together, essentially having like lockstep releases. So one thing is independent release schedule. They want to make this release decision on their own and not wait for others. And the other thing is zero downtime deployments. One thing, an easy example how to do that is take, for example, the customer service. We have the old version of the customer service running. We spin up a new version of this customer service, load balance the traffic between them. Once it's the new one is up and running, we take the old one down. But during that time, we have actually two different versions of our customer service in our production environment, and this would mean that our API or other services that actually use the customer API would have to work with both of them.
If you do it wrong, then you do it like that way. That's the point. So you do it wrong if you have two versions in parallel, and you don't want to allow it. And you have backward compatibility in UIs, or APIs, so you do it wrong.
You mean that if I have two different versions at the same time?
Yeah, and you don't support backward to forward compatibility, then you should not allow this situation.
And yes, if you have both different versions like up and running and they're not backwards compatible, then of course you have a problem. But if they are backwards compatible, for example, an intermediate version you deploy like first before you transition from consumer to customer, you deploy an intermediate version that actually responds with both, then you're fine.
Yeah, and this is exactly what where I'm getting at later. What a customer or consumer-driven contract testing is trying to solve, actually. So, yeah, this was zero downtime releases. So, if they would want to remain backwards compatible, they would still have to. The customer team would have to, first of all, test their changes against the latest billing and inventory service, and also, if they want to go straight to production, they would have to still test their changes against what is in production currently, just to make sure that nothing breaks if they go straight to prod without the other services going there. But this team decided that this was too much work, perhaps, setting up all of these and orchestrating them, so they opted out. But if it seems that this modern architecture has become so modular, perhaps this kind of classical integration testing doesn't work there. So these kind of tests, they are trustworthy in a sense that you will catch this issue that we were talking about. They are somewhat targeted that if there's a failure, you know that the failure was between two of these services. But they are not as fast to run, perhaps. Also more expensive to maintain. Especially if we looked at this scenario where we have a lot of consumers for a single API, and you will have to test multiple versions whether they work together. So we have this testing pyramid. And we just talked about testing one service with multiple other services. So if we go up one level and talk about end-to-end testing, by end-to-end testing here I mean that the entire fictional e-commerce site will be set up in a test environment somewhere. We also already saw that we have the customer and billing service, also the inventory service, and there could be others actually in play here as well. You have some web front-end, accounting, shopping cart, for example. And now you use this e-commerce site through public APIs, and it started to test them, like whether everything is okay. These kind of tests would give you a lot of confidence in a sense that if they pass, you know that your functionality is working. These kind of tests cover a lot of ground. They touch a lot of services. But the same problems regarding backwards compatibility are here as well. So let's say the customer service team would want to deploy their changes to production. First of all, perhaps they will set up this new testing environment with all of the latest services. But this only ensures that they are compatible with every other service, or the head version of every other service. But if they would want to go straight to production, they would still have to test their changes against what is in production, just to make sure that they remain backwards compatible. And with the number of services you have, setting up these environments could also be costly. So they didn't do that as well. So yeah, expensive to create, maintain. Definitely not targeted, in a sense that if you see that something fails, you will have to dig into like where exactly the failure was. You only know that this functionality might not be working. Probably the most slowest to run, and also flaky. And by flaky, I mean setting up all of this. You could run into these kind of situations where one test passes, or the next moment it will not pass, and you don't know what the issue is. So there's this book, Building Microservices, by Sam Newman, and he had this to say about flaky tests. Flaky tests are the enemy. The suite with flaky tests can become a victim of what Diane Vaughan calls normalization of deviance. So this is an idea that over time we can become accustomed to things being wrong, that we accept them as being normal, and we don't consider them as being like an erroneous situation.
And then the real problem sneaks in, and then you don't know if it's a real problem.
Mm-hmm. Yeah, so for example, if a flaky test, you know that it fails sometimes and sometimes it doesn't, and you make a decision that I know that this is a flaky and this is okay, let's go to production. And most of the time it probably works, until this one time when it breaks something. So now I have a question for you. Does anybody know what is this?
It's
Software. Who said Challenger? Everybody. Okay. I thought I wanted to give out the prize for this answer, but I don't know how to handle this situation anymore.
Just keep it.
You didn't do end-to-end.
what line number broke the code?
So yeah, this is the Challenger disaster, January 28th, 1986. And why I'm talking about this, I will get to in a moment. The underlying, this image or picture is taken roughly about, I think, like 73 seconds after liftoff. And what was determined to be the cause of this explosion was a faulty O-ring in the solid rocket boosters. So the solid rocket booster are these two rockets on the side. And their job was to basically seal the gases inside the rocket so that they won't come out of places where they shouldn't come out. So I'm no engineer, but what I have read is that the O-rings, or at least the fault of the O-rings, were known like beforehand. They knew that how the O-rings behaved. Was kind of like the situation where a bug became a feature, meaning that the O-rings they started to leak, but since they started to leak, the leak or the high pressure of gases kind of shifted the O-ring, so it kind of resealed itself again. So this initially this was considered like a failure of design, but later it was written into documentation, and yeah, this became a feature, and this is how it worked. During all of the previous launches, nothing had happened, and so this was considered like acceptable risk, and let's do it like that. Until the day of this incident, that morning was like the coldest launch morning up until that point. Here you can see icicles, but on the background this is the Challenger. The white part, or this white tube, is the solid rocket booster. On the right hand side you have this black grayish part, which is the wing of the shuttle, and on the left you see this brownish thing. This is the fuel tank in the center. So yeah, they consider it as acceptable, and I also already mentioned Diane Vaughan. She is a sociologist at the University of Columbia, and she coined this term normalization of deviance in this book, where he or she investigated the processes inside of NASA at that time, and this is kind of what happened. That like they were okay with this risk. They know that this is a faulty design, but they kind of like pushed it. Nothing had happened up to this point. They kind of like pushed the boundaries all the time, and the new boundary became like the new normal for them until they stepped too far. And then, yeah, this happened. And we don't want this with our applications. What about manual testing? Probably not with the scale of a lot of different services and the high release schedule. It probably will not work for that team.
Also, if you're in the rocket business, then not much of an option.
Yeah.
There's a manual testing actually.
Test failed.
The test succeeded. But then it revealed the failure.
Yes, true. So here is a conclusion of all the different types of tests we looked at. We see that everything that doesn't use mocks or testing in isolation is costly and slow, but the team looked at this table and they thought that, well, if I look this, testing with mocks kind of seems the most optimal solution to like have a high release cadence, but it has like this one big issue that these kind of tests are not trustworthy, meaning that if you change the mock in one side, one service, it isn't reflected on the other side. And this is the place where consumer-driven contract testing comes in, and especially Pact, which is a testing framework which allows you to implement this kind of approach. So to recap, we have billing, customer, they made requests. Here we see the typo, customer ID. But what Pact does is kind of like steps in between them and separates these two services in space and time. Meaning that these two services don't have to actually, to test the integration between them, you don't have to have them both up and running at the same time. You can, yeah, and also Pact adds kind of like two new terminology into this play. We have a consumer and provider. In this case, billing service is a consumer, meaning that it consumes some API. On the right-hand side, we have the customer service that actually provides that API, hence the name provider. So how this setup would work is that on the consumer side first, and this is also what actually makes this consumer driven, is that the consumer is the one setting the expectations for the provider. So if we look at this billing case, we have the billing team would have to set up this this integration where they start the Pact mock HTTP server. They write some setup code which sets the expectations for the provider, how you should behave for any given input. So for example, if I send you a GET request to customer 12, you should respond with this kind of payload. And then they write basically something that kind of looks like a unit test, but it actually makes a HTTP request to this Pact mock HTTP server. How to do that is basically you would isolate some part of the billing service that actually is responsible for this communication, and you instruct this part to make not a request to the actual customer service, but the Pact HTTP mock server. You send the, for example, in this case, the test will send a GET request to customer /12. Pact would see that, okay, have this, I know this endpoint or request, I should respond with this payload. And this test will then first evaluate how this specific component in billing behaved with, when it received this input and either pass or fail the test. In this case, everything was okay. And you might have a lot of these, a lot of expectations, a lot of tests. And when all of them pass, the result is a Pact file, technically a contract that defines how both sides of the integration should behave. A Pact file itself is just a JSON document. On the top you have who's the consumer, who's the provider, and then it's like a list or an array of interactions. So in this case, the same interaction, a request method is get to this path and with this response body.
A question, so it's like a proxy that is constantly running, that you file your suits from either side against, right?
No, it's not constantly running. It's only running when you start your tests. The test itself will, there is some like, the framework itself will do it for you. It starts this HTTP mock server on a separate port, and it will start to record what are you actually sending to it. And if the verification of the test passes, it will produce this Pact file. But let's say in this example, your billing application makes a request to some unknown path that you didn't set in the expectations. This is a failure of the test then, meaning that...
So basically, every time you change the API on provider side, you then need to regenerate the Pact file as an artifact for all the consumers that are dependent.
It's the other way actually. It's the consumer who drives the contract. It's the consumer who sets the expectations, and later we will see that it's the provider who actually verifies whether it behaves like that.
Basically then provider fails.
Yes.
Okay, yeah. Makes sense.
So yeah, you have this contract or Pact file, just a plain old JSON document. And now that you have this Pact file, you can give it to the provider side, in this case, customer service, and you start the test there. It will also set up this Pact mock HTTP server, or actually, yeah, probably not an HTTP server actually, but still. It will read in this Pact file and will start to replay these interactions that were written to this Pact file. So in this case, it will you would also have to set up your customer service as well, but it will actually make a real HTTP request against your service. It will see what it responds, and then it will compare the payload, whether how this customer service responded is actually the same what was written in the Pact file. So in this case, everything is fine. Again, note that this is still customer ID. But as we talked about previously, the customer team, they wanted to fix this typo. Instead of customer ID, it's customer ID now. They made a new build. So let's see how this would have worked if they had used Pact. They started the test, read the Pact framework, read in all the interactions from the Pact file. They started to replay them against the customer or running instance of a customer service. Now customer service responds with the fixed field name, customer ID. and this would have immediately failed the test because this payload doesn't match with what was written inside the Pact file. Let's say you want to use Pact.
Sorry.
Yep.
But if we have many customers for our customer, then each of them provide their own Pact, and if we change small change in our code, then we get a lot of broke Pacts. Yes.
Yeah, if they depend on what you changed,
And
then
that's
yes,
good.
that's actually a good thing.
You can do change that break your consumers and deploy it into production.
Okay.
Mm-hmm.
So previously you showed that consumer developers on consumer side just change the test to pass. What stops me on the provider side to just change all Pact files?
Write the
new
application
version.
to change all Pacts.
And
But
write-
actually, a good thing that you asked this. Previously they just fixed the test, but this time, if we want to start, if we want to get a new Pact file, you would have to go to the billing application and fix the billing application so it actually conforms what you had in your customer service.
So these Pact files are not in the same repository? Where do you store them?
We will talk about this later. But if you really wanted to do that, you could just edit the JSON file, but this will probably, or at least should have rang some bells that you are doing something wrong.
Yeah. If you end up like in a situation when you edit the Pact file, then it's obvious sign that something is going wrong.
Mm.
You should not be normally doing this.
But the first part was also you're changing contract. Doesn't matter how it looks like. It still should start some bells.
Well, actually, when you fix the test, you don't always know that if you fix the test or you fix the test just for sake of fixing it, or you actually adjust it to the new implementation.
There is another thing
It's-
also. So sometimes you don't know whenever it actually impacts someone, because, for example, you realize, like, okay, I just built a brand new API. Maybe no one uses that. I find a typo, and I know next day, and I fix it because it's a typo. But actually, another team has said, "Oh, they released a new API. Let's start using it immediately," and you don't know it.
But if you use versions, then you have two versions afterwards.
Yes, if you use versions.
In that case,
But,
it's
And
not-
sometimes you have a version madness in this case.
Yeah, but the versions you kill them after some time, so you
Yeah,
give,
if,
time
and
for
if someone is still
two-
using
2
that, and
months.
then
Yeah.
Yes, but for example, if you serve an API, versioned API for mobile devices like Androids, you have like not much of control to deprecate versions that easily. Then
yeah, you actually
You
in
have to
mobile
maintain
applications
them.
deprecate usage if it's not updated. That is also the case.
Yep,
It's
you
an
have a
application.
question.
But this is not the problem.
So if the Pact file is not in my repository and it's some other service, they can change this Pact file whenever they want and my service will break.
But then their service in production will break. So they
But we will talk about that one as well.
Also like weird.
Uh,
even to test team.
I was, let's say you wanted to start using that. Pact itself is the implementation is written in Ruby, but let's say you have you use different platforms. Let's say in this case, billing is written in Node and the customer service in Java, and this is completely fine since Pact itself is like kind of like a specification. There are a lot of implementations or libraries that make use of it, and for example, even the Pact mock HTTP server has a REST API, so you can even set the expectation using just curl, for example. And when we again look at this testing pyramid, this consumer-driven contract testing kind of you can run these tests kind of in isolation. They're kind of like unit tests, but they test the integrations, or they are like in between these two, for example. So perhaps they don't fit in this classical diagram, but they are somewhere in between there. So yeah, sharing Pacts. How do you do that? Since you maybe have two different teams working on different floors, for example, how do you give the Pact file to the other team? One thing is, if you have your source code repositories, let's say all of your services live in one repository, for example, then it's super easy. You just commit this Pact file to your repository, everybody has access to it. Or let's say all of your services live in different repositories. Then you could, for example, on the consumer side, you configure your CI build so that it will actually commit this new Pact file to the provider side repository, for example. Question?
Do this framework have some kind of state machines? Like what if I need to test login flow or registration flow? Can it understand that I should make multiple steps and check if the state was preserved in the right way?
If you want to do that, you would have to make your test stateless or stateful.
You can make login flow stateless because it has state.
But it's not about testing of contract. If you want to test the flow, you will do it in, for example, end-to-end testing.
So you basically
So
you
you
can
isolate
yes,
it on steps.
yes.
Here you isolate just the integration between two services, and then if you want to test some hard flows, user interaction, it's for another layer of testing.
Yes, basically you can use other tools for testing like entire scenarios, and then help testing contracts with services like right there with Pact. So basically like testing contracts and testing like complex scenarios is two different problems that are solved.
It's not about the scenario because some API calls you can't access by a single call. For example, to unblock it, you should make a first call and then you can, for example,
If you have access token, then
Access
it's
token,
one
you can-
response.
you
If
can,
you don't have
make
it, then
another.
it's second.
But here is everything mocked, so you can emulate both situations in isolation.
So you like can prepare states and then test steps.
The back framework has this concept of provider states. Although, you're testing the contract, meaning that if we speak the same language, but we don't actually perhaps test like these larger scenarios. But there is this concept of provider states that you can, the consumer side can set in this Pact file that what is the state of the provider that it should be in. For example, the state is user not logged in, for example. And on the provider side, the test will read the state and somehow modify, I don't know, the database or something for that particular contract test. Pact itself or contract testing isn't used for testing like large scenarios. You only test this single API request technically.
I think they don't recommend it in official documentation to use these states.
Basically, it's the contract testing more or less.
That's something we're discussing.
It's a very technical presentation.
So the other way to add or share Pact files is, for example, if you have your artifact repository where you store your builds or packages, it is possible to perhaps add them there. If you have an accessible network file share, you can upload them to there, for example, so other services can access it or service builds can access it. You can make it available via an URL. You can come up with your own URL scheme and make it available to others. There's also a library that you can use to automate this process using AWS S3, for example. These are all good, but there's the recommended approach is to use what is called a Pact broker. One thing that it does well is shares Pact. So this is the scenario we already saw, that on the consumer side, billing will set the expectations, then actually run the tests. If everything is okay, then a Pact file is generated. And then the next step is to publish that Pact file to the Pact broker. And on the provider side, the framework will just connects to the Pact broker, it tells that I am a provider, my name is customer, and it will give you all the Pact files that are related to this provider, and you can then start running all of these interactions against customer service. The other thing that a Pact broker does is it starts to version your Pacts and your applications, or a different version of your applications as well. So what I mean by that is, let's say that we have a version 1.1 of billing and 1.1 of a customer. And the green check mark between them is that the verification between them has succeeded. The Pact tests run well. And this gives me this confidence that I can deploy these together to production, for example, and they work. Also, let's say that we have version 1.0 and 1.0 of customer and billing. And there's also a green check mark, meaning that the verification between them has passed. Because although I have marked them that these versions are currently in production, but I know that at some point they were the latest, and we verified the latest latest versions of these two services together. But there's two empty slots in this matrix. So for example, if the billing team wanted to deploy their latest version 1.1 to production, they would perhaps look at this, see that there is no verification result between the customer service that is currently in production. So they don't know, are we safe to deploy our changes to production. What they can do is, for example, check out the production version of customer, run the Pact tests, which actually will go and fetch the latest billing Pact, run the test, and for example, if it failed, they know that we as a billing team, we cannot deploy our changes to production because we will break something. Another example is from the customer service side, is that if they want to deploy their latest changes to production, they would have to make sure that it will function well with the billing version 1.0. And how they do that is they check out their latest 1.1 version of customer service, and they ask the Pact broker, give me the Pact that was produced by 1.0 version of billing. And they run this test. Let's say if it passed, then they know that we are safe to deploy our latest changes to production. And this essentially is the Pact matrix. And a screenshot from the Pact broker itself. You have on the left side different consumers, on the right side different providers, and it will show you the last verification, but you can click in and basically view the history of all the version compatibilities as well. Another thing is that here I showed you that Pact broker kind of knew that some versions are in production, and how that works is that with a feature called tagging. You can basically say to the Pact broker that let's say version 1.0 of customer, I will add a tag named prod to it, so I know that this one is in production currently. And I can use that to later fetch the production Pacts technically. There's also a set of command line tools that come with Pact broker. One of them is can I deploy, and this technically automates this check, what we were doing here in this matrix. If you run this, let's say this example, I want to deploy the latest or 1.0 version of billing to production. This can I deploy tool technically queries the matrix and checks that whether this is fine. So if it is fine, it will say, computer says yes, you can do it. And since this is a command line tool, if this check fails, it will return with a non-zero exit code, and you can easily add this step to your deployment process, and it will basically fail that for you. We will talk. So there were some comments regarding dependencies that sometimes you might not even know who is consuming your APIs. So if everybody in this fictional e-commerce site every service is integrated well with this Pact broker, you can actually draw, or Pact broker will happily draw this graph for you. You can actually discover who's using who. And maybe perhaps in a large organization, you discover that I didn't know that even this service uses my service, for example. So yeah, it knows all the dependencies. So different steps, a lot of things to consider. Can we automate all of this and make our lives easier? I would say that there are like a lot of different workflows you can build upon this. It really depends on how your organization works. But one example in this fictional e-commerce site, you could, let's say on the first of all on the consumer side, you set up the CI build for billing, which for example, I don't know, compiles code, builds it, runs some unit tests. Then it will do actually this Pact test step that we were talking about, and it will produce the Pact file and then publish it to the Pact broker to make it available for others. Then let's say we configure a customer service CI build, and it will more or less do the same things. Initially build, run unit tests, and then it will. The next step is it will start to verify the Pact, but it will ask from the Pact broker, give me the latest Pacts that are related to me, and it will verify all of them. This ensures that whatever change was made to customer service is compatible with all of the latest changes from every other service. And the next step, the final step, could be it will verify the Pacts that were made by the production versions of the other collaborators. And this ensures that whatever change I made is actually backwards compatible with everybody else. And this test is then kind of done in your CI build that you run continuously all the time. So you will start to catch these errors if you break backwards compatibility. Pact broker has this feature called webhooks, and you can integrate this into the CI system as well, meaning that, for example, on the consumer side, if a new Pact is published and the Pact itself is semantically different from the previous one, Pact broker will call this webhook, and you can, for example, trigger the provider CI build from that, and you will get immediate feedback whether the provider side is okay what you did. Then you would you set up the CI pipelines. You set up the webhook. Then before you deploy, you add this step. Can I deploy? This will ensure that it will break or stop the deployment if it discovers that you are not allowed to deploy this version because of it will break something. And the final step after the deploy you should do is tag the new production version of whatever you just deployed in Pact broker. Then this is important because then this step will work later on. So yeah, backwards compatible changes. And now we know that every time we make a change, let's say on the provider side, we will get immediate feedback that whether we have broken any of our clients, for example. So let's have a look at this scenario again, that we have this new customer service that fixed the typo that we were talking about. We have the Pact file from the latest consumer build. We run the test or replay the interactions. This is the fixed payload, and we see that the test failed. But instead of like going and knocking on the billing guys or team's door and say, like, go ahead, fix your application, what we could do is make this change backwards compatible. So instead of renaming this field, we could add a new field to it. So now we have consumer and customer ID. Since nobody's still using this customer ID, this test will pass and everything is okay. And now you can notify the other teams that, hey, the API has changed. If you have time, go and fix your client.
The tricky part with that approach, I mean, it's a really good one, but the tricky part with that approach is that you have to remember to clean it up.
Sure.
Otherwise it's not really good.
It's your goal.
Yes, but it's
we need to know
normally, yeah,
who is using which version.
as it goes with teams, there's like many people working, many teams, people come, people go, and it can get lost.
And when all this JSON validation contract, someone say, okay, a known field appeared, do something with that. I just got broken 500, everything is down. So, okay, shaky.
But let's say everybody has agreed, or at least they know of this change, and they can, you can basically notify that now this one is deprecated, please update if you have time. Over time, perhaps others will take notice of it, and since you are using Pact, you can actually see what they are using. And if you see that over time, you can test, like for example, delete this line. If it fails, somebody's still using it. Or if you delete this line like this and the test will pass, then you know that all the other clients have stopped using this field.
The only thing you know is that all the clients have removed this call to this field from their tests.
Yeah, only
But-
for tests.
But
Yes.
they might have stopped using this like long before that. And but this is of
Or
course
vice
like,
versa, we don't have it in test.
or yeah, but then the,
But if you don't have it in the test, then it will not appear in the Pact file as well.
yeah.
So what is in the Pact file is actually the things that you used in the test.
Yeah, but this is another problem, like how tests are actually correlate to
Real use.
what
Real
your
use,
application
yes.
is, yeah. I mean,
Mhm.
yeah, one token that's all fault, obviously.
So yeah, this is like one way to do backwards compatible changes. Yep, you have a question?
Can you somehow mark those deprecated fields in Pact so that all the users see that it should be changed now?
No,
Or
not that I know
you
of.
Go to every consumer.
You could-
Provider can change Pact of consumers. So as a provider, you're not able to control the Pact file. So you cannot annotate anything there.
Yeah, it's the consumer who actually like sets the expectation, and that's why it's called like consumer driven. And well, you could use other. I think you could other methods for it. For example, you have some, I don't know, you use OpenAPI to document your API, and you can mark that field as now this is deprecated, for example. Or you could just tell them not stop using it.
I have a hard time like coming up with a solution. What if I have a API proxy in the middle, which you have a consumer,
Mm-hmm.
producer. So API proxy would be a producer. You would create contracts or these Pact files for the proxy, but then
You have a separate contract between the proxy and the other thing you were talking about. So every link has a contract technically in your architecture.
Basically, in between every direct communication, there is a contract. So if you have a proxy, then you have two contracts
Mhm.
like on each side of the proxy.
yeah, but if proxy is down, it doesn't know exactly who's getting called or who's calling this proxy. It would it would need a lot of definitions for this, right? For these contract
Don't use
tests
proxy.
to work.
So you're saying that the proxy itself is like super dumb. It doesn't know anything about the payloads that come in or
Yeah, maybe it just looks at some headers and
routes
loads it
them.
or something.
Yeah.
And
But-
only for this use case, you would like need to
But the-
define all of the incoming pacts and all of the outcoming pacts.
But it's in that sense, this proxy, it doesn't modify the payload or anything like that, right? It just passes
For now,
through.
Yes.
But in that sense, I think that if we look at the tests, and then the contract is still between you can leave out the proxy and you still have two parts that have the contract. but it's the proxy that just passes the information, right?
And one day you change your proxy,
Yeah.
and that's it.
So well, yeah, you change
Well,
something.
Yeah, once proxy starts doing something, then it's no longer just a proxy, but like a carrier of piece of business logic, and then it is separately.
Mhm.
Yeah, it starts to add more headers.
I know.
Yeah, you test that. Yeah.
Question.
Maybe you don't need to do a lot of logic on proxy.
Alright.
Oh,
There
that's
was
a
a-
philosophical discussion. Yeah.
So the tests, are these for the exact values or can you test against data types?
Yep,
or-
data types, you can add, I don't know, regex there. This format is okay, for example. But yeah, data types are okay. So it's usually not recommended to test against exact values. It's you are not testing you're testing the contract, whether the fields and the data types and everything fits, but you don't test the functionality actually.
Okay.
If you want to test the functionality, then you run some tests locally to give input.
Structure of JSON, names of fields, types of fields.
Okay, I understand. Let's say the consumer side defines the new expectations for an API, and you start from 0 lines of code. How do you know what the expectations are? This kind of describes if you have a setup that works, how do you manage the changes, but how do you start to realize the API in the first place that it should answer with these kinds of values, these types of values?
I guess there are like multiple ways to do that. One thing you can do is use contracts to actually drive the expectations. You as a consumer, you said that I would think that this kind of interaction is fine, and you will give it to the provider team that, and you start this discussion like, is this okay? What do you think? And can we do that? And this is kind of like also a test-driven development approach that you already have this contract in place. If the others, you discuss with the other team and you see that this is fine, they can implement this contract, and they have also already a test to like verify that whether it works. So kind of like a TDD, but on a.
It's more like a discussion about API. What we need, which data we need, and in which formats. That's all. So when we start, we just assume that we will get this and this data. That's all.
But if a response with customer ID 10, so just say it's still fine, right?
But you can expect a number there.
You just say that this has to be a number, not a string or object or something.
Okay, but I mean that's a question about exact value. So if response 10 but not 12, and actually you're asking for 12, and there is some dummy logic, I don't know. So it's still from contract perspective that's okay, right? So it's a problem of business logic, and you have to test it on different levels.
enums, for example, if there are several enum values, what you need to check, for example, represented as strings probably in the JSON. So those must be checked probably.
There's a question behind.
Yeah, I have one question. Like, can I push like the definition of the API from the provider side also, like as a contract?
No.
Because like my point is like I can always give more data than is expected from me.
Yes.
So I can't push like my data definition from the
Uh, you can add like more data to the response, but if nobody is using it actually, then it doesn't have to be tested with this contract.
So where do I get to know that this data is now available for me from the consumer side?
This is
It has to be like separate from the contract.
yes. How you know that what has changed in the API or that this is not what consumer-driven contract testing covers? You can use, I don't know, Swagger or OpenAPI to like define like this is my API currently. These are the new things or whatever. But yeah, the consumer-driven contract testing, at least with Pact, doesn't allow you to now notify the consumers that hey, this new API has become present or something.
So the consumer basically should put to the Pact file only those fields what it actually uses.
Otherwise, you could run into. Otherwise, the provider would have to like take into account whatever you put in the Pact file, but it could be that you don't actually use it.
So a public API that you have running one day starts printing out plain text passwords, so this framework would still be okay because no consumer expects to get that.
Yes.
Okay, cool.
But public APIs might be tricky because
Mhm.
because the problem will be then how do you collect the Pact files from all the consumers because there's really a lot of consumers.
Yep, that is true, and this is it's not probably not recommended to, or you cannot actually use this approach because you don't know your consumers. And if you have a public API, you have like more strict rules, I would say. So to sum it up, this kind of approach with Pact forces you to think about backwards compatible changes and how to do them, and it will notify you that whether you actually broke backwards compatibility. It lets you like evolve your API independently. You probably can get away with even not versioning your API, and it helps you like easily test the interactions or integration points in your architecture. But yeah, as we discussed, this approach does not work everywhere. It could be that even, let's say you are in the same organization, but the other team is not on board with that, then you still cannot use that. Everybody has to be on board to use this consumer-driven contract testing approach. And yeah, for public APIs, very difficult to do that. You could probably like create your own mock consumer that actually consumes all the APIs, and still this way you will know that if I accidentally broke something, but you don't know your consumer still, you don't know what exact endpoints, for example, they are using. There is an alternative also. If you live in the JVM space, for example, the Spring Cloud portfolio has a project called Spring Cloud Contract, which kind of does a similar thing. Although I don't have much experience with that, but it's kind of like limited to JVM. You write these in Groovy, store them in some artifact repository, and probably doesn't, I might be wrong, I haven't used that so much, but it doesn't probably work with other platforms so well. So, but yeah, that's about it. If you have still other questions, I have a couple of hoodies to give out. There are like has been like a lot of good discussions around that, but a question?
What would be not consumer driven, but still contract test?
You could, for example, I'm just like taking this from the top of my head. You could probably come up with a scenario where the provider is actually the one who's making up this contract, for example. But I don't know or I cannot give you like a good answer to that.
But I have a question.
Yep.
Now everyone is moving
But you asked the question at the right time. We'll get a hoodie come by here after. Yep. Question.
So about everyone is moving into async world right now.
Mhm.
Even shops you showed, there's lots of async functionality
Mhm.
with messaging and streaming, it's called this Lambda architecture
Mhm.
stuff or whatsoever. So I guess in that case, nothing from that works.
When I talked
Because
about
it's also a contract because message is
Yeah,
a contract.
true. A Spring Cloud Contract has they cover Kafka and RabbitMQ. They have integrations with them, and although I have read about Pact as well. I have seen some GitHub issues that actually tell that it is possible to use, I don't know, JMS or something, but I haven't seen any good documentation about that. But it's actually true that if you have a lot of asynchronous stuff going on, then it becomes more difficult because, let's say, even if you send a message through, I don't know, RabbitMQ, for example, you don't have this traditional consumer and the provider who actually responds you with something. You only have this like one-way messaging.
It's not only about asynchronous. If you use instead of REST, for example, gRPC, it is also not possible to use Pact.
Actually, many projects start using WebSockets, things becomes more complicated.
Mm.
Yeah, with WebSocket there's the same problem with the message queues of any type pops ups. It's also the same problem.
Mm. But it will get hoodie as well. So I only have 2, but if you have still more questions, you can fire.
We can fit in one more question, and then I think we'll call it a night. So, everyone.
Everyone is sleepy already.
Ah. What about pricing?
No pricing,
No
open
pricing.
source.
Open source software.
Okay.
Is there any documentation generator?
For Pact or
Yeah, if you have Pact file and can you generate a documentation that is pretty shiny and can be shown to everybody?
It's called Swagger.
Why I need 2 descriptors for Swagger and
that's actually a good question. And if you read the docs in from Pact, you can actually they also will tell you that isn't Swagger the same thing or something like that. But they clearly say that Swagger itself the idea is to document your API, but the Pact itself is a testing tool to test the contract. So 2 different things actually. But yeah.
but they both describe the structure of the
But they don't, as we were talking about that, if you don't use an endpoint, for example, but it's still present in the API, then it will not be in any of the Pact files. So that, in that sense, it's not possible to have it in your documentation if it's not in the Pact file.
But Swagger has testing tools as well,
But
based
there,
on the schema.
and actually, there's an integration with Pact and Swagger that is done by Atlassian. They have some integration with that as well.
Okay, so maybe yes to your question. Alrighty then. Thank you so much. Thank you, Starship people, for having us. Thank you, Indrek, for joining us for this DEVCLUB.
Thank you.